Hi, my name is Andrew Stovall, and these are my recommendations regarding the conservation of angiospermic trees with the exception of palm trees in Indonesia. Just a little bit of background about Indonesia's angiosperms. Indonesia is home to anywhere between 25 and 40,000 species of flowering plants and trees. Roughly 40% of those are only found in Indonesia. They exist nowhere else in the world, and their seeds can be dispersed by wind, water, and animals. There were a few different methods of analyses conducted: species abundance, species richness. Two different diversity indices were used: Shannon Diversity Index and Simpson's Diversity Index. Population composition and density was looked at, as well as endemic species and vulnerable species. This table here is more or less a compilation of all the analyses conducted on the assemblage. Island number one, which is the largest, is home to the greatest number of species at 16, followed by island number three with 8, then island number two with 5, island number four with 4, and lastly the smallest island, island 5, with 3. The number of individuals follows the same trend, with island number 1 home to 92 individuals, followed by island number 3 with 35 individuals, then island number 2 with 19 individuals, island 4 with 13 individuals, and island 5 with 8. Two different diversity indices were used on the assemblage: the Simpson's index and the Shannon index. The Shannon index can be skewed by rare species, so the Simpson's index was used to avoid any bias one way or the other there. The Simpson's index gives more weight to dominant species. The outcome of those two analyses are consistent with what you'd expect based on species richness and number of individuals. Island 1 is the most diverse, followed by Island 3, then Island 2, Island 4, and lastly Island 5. Island number 1 is home to a whopping 9 endemic species. The only other island home to any other endemic species is Island 5 with 2. There were also 2 vulnerable species in our assemblage. Island 1 is home to both of them, one of those being the rainbow eucalyptus or Eucalyptus deglupta, the second being the teak tree or Tectona grandis. There were also analyses conducted based on species composition and area relationships. Island number 5, which is the smallest island, has the highest species density at 0.38 species per square kilometer, followed by island number 4 at 0.21 species per square kilometer. Island number 2 and 3 follow that, and last in that category is island number 1 at 0.17 species per square kilometer. In terms of the density of individuals, island number 1 and 5 are tied at 1 individual per square kilometer. Then island number 3, 0.88 individuals per square kilometer. Island number 2, 0.76 individuals per square kilometer. And island number 4 at 0.68 individuals per square kilometer. Across all 5 islands, there are 19 species and 167 individuals. So to succinctly summarize the data introduced on the previous slide, Island 1 is the largest, home to the most species, the most individuals. It's the most diverse. It's home to the most vulnerable species and the most endemic species. Island 3 is second to Island 1 in number of species, number of individuals, size, and diversity. Island 2 is third in number of individuals, species, size, and diversity. Island 5, it is the smallest of the 5 islands. It's the most isolated. However, it is the most species dense. It's tied with Island 1 in terms of number of individuals per square kilometer. And it is the only other island other than Island 1 that is home to any endemic species. Island 4 comes in at fourth in most of those major categories. When looking at how the data adheres to some common ecological patterns, we find that of the four common patterns of diversity, we can't draw any concrete conclusions. We don't know if the most diverse islands have an intermediate amount of disturbances for diversity productivity relationship. We don't know whether our most diverse islands are most productive. And for the latitudinal gradient, the geographic orientation of our islands are unknown, so we can't say whether or not the islands at lower latitudes are more diverse. However, for the species area relationship, all five islands did adhere to that, in that the islands that are of the largest size in terms of land area do have the most species. For the three common patterns of abundance, we can't draw any conclusions about species being most common at the center of their range. We don't know what their range is. We don't know if they're most common at the center of that range. We can, however, we do see that most species are rare and few are common. Only 2 out of 19 of the species have 15 or more individuals on an island. 3 out of 19 have 10 to 14 individuals on an island, and a comparatively large amount, 12 out of 19, had only 0 to 4 individuals on an island. Similarly, we do see that common species do tend to be widespread here, and rare species do seem to be restricted. 3 out of the 5 common species, that is, species with greater than 10 individuals on any given island, are found on more than one island, so they are widespread. And 9 out of 14 species with less than 10 individuals, the rare species, are found only on one island, so they are restricted. Based on all the data within this presentation, it is my recommendation that islands 1, 2, and 3 be protected and conserved. That would bring us in under budget at 471 million rupiah. Island 1, because it is the biggest, most diverse, home to the most endemic species, the most vulnerable species, one of which is only found on Island 1, that is the teak tree. Island 2, because it's third in diversity, size, species, individuals. It's also home to one of the vulnerable species, that is the rainbow eucalyptus. Island 3 is second in size, diversity, species, individuals per square kilometer, and it's also home to one of the vulnerable species, the rainbow eucalyptus. When looking at all three of these islands, they're very close in proximity to one another, so it's not far-fetched to say that any birds transferring seeds from one island to the other would have an easier time doing that with the seeds of these angiosperms rather than islands that were not within close proximity to one another. The principles of island biogeography tell us that there's also lower chance of extinction because these islands are the biggest islands. There's lower competition because they're the biggest islands. There's more core habitat, and if there are indeed negative edge effects, there would be less of those. However, there are a few caveats that I'd be remiss not to mention. Most importantly, no environmental data is accounted for here. So things such as soil quality, habitat quality, resource limitations, and a slew of other potentially extremely important abiotic factors aren't accounted for. So for example, it's unknown whether a species that's endemic to a particular island could be transplanted successfully to another island, or whether the island that it currently exists on just contains the perfect mix of resources. Also, Island 5 could be in consideration here, as it is the only other island apart from Island 1 that is home to any endemic species. And there could be an argument that isolation could be a good thing, as in the event of a contagious catastrophe, islands closer in proximity to one another would be more susceptible to decimation. That being said, this is the conclusion of my presentation. Thank you to the Indonesian Ministry of Environment and Forestry.